guys. Well, today we're going to talk a little bit about the Big Bang as a physics model for how the beginning of the universe happened. Let me tell you that I'm a little bit overwhelmed by this because it's a hard lecture to give, particularly because there's a lot of people that have apprehension about discussing things that may or may not have an easy correlation with, say, sacred texts that they're familiar with or that they subscribe to. We're just going to be talking about this from a scientific perspective, so you can rest assured there won't be too much philosophizing on this point. We will kind of cover some misconceptions about the Big Bang in this video, and then we're going to go on to the science of the Big Bang in subsequent videos. So that's kind of what's on the menu right now. So I'm going to start this little segment just by saying that right now I'm writing a book about the Big Bang, and I've carefully crafted the opening sentence, and I know it's good because my wife loves it. This is the way it begins. It says, "Nothing is more insulting to all that is beautiful or complex in this world than the idea that it came from a cosmic explosion." And the reason why I start the book that way is just to say, look, we get it. We physicists get it. This is a lousy story for the origin of the universe. But that's not what we're after. We're not here to tell a good story. What science is actually about is trying to explain what we see. And science favors very simple models for doing that. Now, it turns out that science actually doesn't believe in a big explosion that started anything, at least not in the sense that a lot of people think of in terms of an explosion. But there is a difference between science's desire to have a predictive model that, say, predicts accurately the characteristics of galaxies, and, say, the humanities' emphasis to try to answer the questions of the soul about why we're here, where we're going after we die, or what the purpose of life is in general, or what beauty is, or what truth is. These types of questions are not scientific in character, or can't be treated scientifically. Science is just about getting a predictive model, and the Big Bang theory is a very minimalist structure that sort of answers those questions. So with that, let's go ahead and just start talking a little bit about this thing called the Big Bang, if that's okay. So misconceptions, first of all. Misconceptions about the Big Bang. There are a lot of them. The first is kind of funny, is that the Big Bang says that the universe began in a Big Bang, which you would assume that's what the Big Bang says, if that's what the theory is called. The truth is, it doesn't actually say that. What the Big Bang theory says is that the universe was once very hot and very dense. But it leaves open the question of why it got that way. And there's a lot of theory that we can take to kind of extrapolate backwards and figure out maybe what happened at the instant of creation or the instant the universe was made. But we don't, the Big Bang theory itself as a structure does not actually make a comment on that time. It just says the universe was once hot and dense. And so that's going to be the point that I'm going to try to convince you of, not necessarily how or why it got there. One of the other major misconceptions about the Big Bang is that it was a big explosion. I'm going to put cosmic firecracker here on the notes. One of the reasons why the Big Bang strikes a lot of thoughtful people very offensively is that it seems to say, just the words Big Bang seem spectacularly callous and irreverent. And it seems to say that the delicate beauty of a rose emerged from this clumsy, loud, billowing explosion from the beginning of time. And that's not what the Big Bang is actually saying. Explosions, as you and I know them, are extremely highly chaotic events. They're high entropy events, and they increase the entropy of their surroundings. They destroy things. They're bad. The Big Bang, as an event, was the lowest entropy event in the entire universe. In fact, it's so spectacularly low entropy that there's virtually no physical process that you and I can think of that would create a universe that was that low in entropy. So as far as organized events go in the universe, the placement of atoms was so precise in the early cosmos that it's left scientists scratching their heads and wondering what types of cosmic processes would give rise to such initial conditions. So What's the truth here? Is it a cosmic firecracker? In fact, it's a low entropy event. And that's kind of important to keep in mind. Kind of related to this cosmic firecracker idea is that there was an object that exploded, and that's what made the universe. I hear this one a lot. This is what the assumption is. That's not the case. Every location in the universe was the location of the Big Bang. Every corner of the infinite universe was filled with energy in the very early universe. And because of that, it's not explosion-like at all. There wasn't an object which exploded somewhere in space. Space and time themselves emerged into existence at the moment of the Big Bang. So, it was an object that exploded. Well, the correct answer is that space and time came into being then. And that the Big Bang happened everywhere. And that might seem a little strange, right? That the Big Bang could have taken place everywhere in the universe at the same time. But that's what the mathematics tells us. The final misconception that we'll talk about just in this video, and then I'm gonna sign off and we'll talk about other things in a little bit, is that the universe is expanding right now into previously unoccupied space. So the picture is that the universe consists of this glob of galaxies, and that as the universe expands, this glob of galaxies is getting bigger and taking up space that is formerly unoccupied. That is not the case. We are not expanding into previously unoccupied space. What's happening is space is infinite, and distances between points is getting larger. So the distinction here is this: if we had infinity first graders and they were all standing 1 foot apart in a line stretching out to infinity, and I asked those first graders to arrange themselves such that there's now 2 feet in between them instead of 1 foot, they could do that because space extends infinitely in either direction. Yes, there's an infinite number of first graders, but there's also infinite space. So there's room. They can expand out that way. That's sort of the picture that we envision. There's no edge of the cosmos. There's no place where we run out of galaxies or run out of stars, at least as far as we know. And our mathematical models just treat it as if space keeps going and going and going, because that's, for all we know, that's all that we can see. And so we assume that distances between points are getting larger. That's what we mean when we say that the universe is expanding. Next misconception is that the Big Bang violates energy conservation, or that it allows faster than light travel. I've heard this objection from some deep thinkers. They want to know how things can move faster than the speed of light, because some models of how the universe began include that. It's a good question. I'm going to answer it next time because we're kind of out of time here. The answer to that question is that none of those things happen. This is good physics. No rules are broken. So, it's probably worth pointing out, too, that there's individuals out there that have... oh, actually, here's one more thing. One more thing is that the Big Bang is the atheists' alternative to scriptural stories. And that's not true either. Both people of devout faith and strident atheists alike recognize the Big Bang's impressive predictive power. In fact, there was a scientist whose name was Lemaitre that lived around the same time as Einstein. And when this discovery of that galaxies were moving away from the Earth was first discovered, Lemaitre correctly realized that could have meant that the universe had a beginning. And being the Catholic scientist that he was, he celebrated it and thought that this was finally evidence, concrete scientific evidence for him that there was a God. You have an infinite a universe that's been around for an infinity of time. Well, it's harder to see how, in Lemaitre's mind, how a God would be needed. But if the universe began, then that was a job that God could do, is start the universe. He also was in love with the idea that everything began in the universe as light, which the Big Bang predicts for the first tiny fraction of a second. All the matter and energy in the universe was in the form of electromagnetic radiation, which turned into matter and antimatter, and then ultimately became the material universe that we see today. And so he thought that that harked back to Genesis 1 and really latched onto those ideas as being evidence, believe it or not, of his beliefs in a creator. So you have people on both sides of the spectrum, and the point is that the Big Bang is science. It's not trying to comment on the purpose of life or on the meaning of life or the meaning of creation. All it's trying to do is to try to predict what the character of galaxies are throughout the universe and to explain some of the things that we see when we look up at the night sky. So it really is just science. And in fact, it's impartial on those big humanities questions, which are important questions, but questions that we as scientists just can't answer. Okay, well, that's going to be the first part. I'm certain we've gone off into the weeds quite a bit already, but I hope maybe you identify some of the things in yourself when you think of the word Big Bang, and maybe I've touched on some misconceptions. It's not what you think it is. The model is a little more subtle and more complex, and it's certainly not the big blundering event that people joke about taking place at the beginning of the universe. It was a highly organized, spectacular event that took place everywhere in the universe at the same time, where the universe was shortly thereafter filled with high energy light, which ultimately became the matter that we see around us. It's a little more subtle, I guess, than the clumsy cartoon pictures we sometimes paint in popular culture. So I'll see you next time, okay?